2012 calculus free response question number 3, part D. For x between -4 and 3, find all values of x for which the graph of g has a point of inflection. Explain your reasoning means we're going to have to justify that. So we want to find a point of inflection. So, and remember that what we figured out in our previous parts is that they keep asking us about g. And as long as I understand this relationship between g and f, I know that this graph up here is the graph of g prime. So I'm asked questions about g, I'm given a graph of g prime. So we need to understand what about g prime tells us that the function g has a point of inflection. So we're going to go back to our calculus chart of awesomeness, which describes all the awesome properties of functions relative to f, f prime, f double prime, and the graph. Now we're looking for an inflection point. Now, if f double prime is 0, we have a possible inflection point. That's not going to be good enough for us. What we need is definitely an inflection point. And here's the two places where we get an inflection point. Either f double prime changes from positive to negative, or from negative to positive. And another way that we can find the inflection point is the definition of inflection point. Point of inflection means concavity changes. Now another important thing, since we don't have f prime and f double prime here, let's look at, we just have a graph of, really it's g prime. So we have a graph of the first derivative. So let's look at some more things that could give us an inflection point. Notice how if f prime is increasing, then we're concave up. And if f prime is decreasing, we're concave down. So if we want a point of inflection, that's where the function f changes from concave up to concave down, or vice versa. That means f prime, and we like that because that's what we have a graph of, changes from increasing to decreasing, or from decreasing to increasing. So that's what we're going to look for. We're going to look for f prime, or for our function it's really g prime, to change from decreasing to increasing, or vice versa. So we're going to look at where it's increasing and decreasing. So here's our graph of g prime. So we're going to look for every place that it changes from increasing to decreasing or vice versa. So one thing I see is that we start out with an increasing function. Then right here it starts decreasing. So right at this point, which is x equals -1, at x equals -1, we changed from increasing to decreasing. So that's already one of our inflection points, x equals -1. Where else does the function change from increasing to decreasing? Well, we're decreasing. Here we're still decreasing. Oh, but right here we start increasing again. So here we were decreasing, and here we're increasing. So right here, this function changed from decreasing to increasing. So this, x equals 0, that's another point of inflection. G prime changed from decreasing to increasing. Looks like right here, we were increasing, and now suddenly we're decreasing. So right here, that's at x equals 1, the function has changed from increasing to decreasing. So whether we change from decreasing to increasing, or increasing to decreasing, or increasing to decreasing, any change, increase to decrease, is a point of inflection. So the points of inflection are x equals -1, x equals 0, and x equals 1. These are the points of inflection of g because g prime changed from increasing to decreasing. So now we can simply answer the question that way. We can say g, and we have to specify it's g that has these properties. G has points of inflection at x equals -1, x equals 0, and x equals 1. And now we need our justification point, so we're going to say because g prime changes from increasing to decreasing, and we can say or vice versa. Now we can say at x equals -1, x equals 0, and x equals 1. I'm going to avoid the redundancy and say at each of these points. And that's a complete statement that tells me that the points of inflection are at these points, and the reason is because G prime changes from increasing to decreasing. And that's our final answer to part D.